a submarine that can dive through Titan's methane seas, a celestial hopper that can harvest frozen nitrogen as propellant. These are the types of futuristic spacecraft that could explore distant worlds for us. But while they look straight from science fiction, there's actually an in-house conceptual design team at NASA behind them.
I'm Steve Olson. I run the NASA Compass team. Compass was begun in 2006 during the Constellation program. We put the team together to basically design lunar landers. How do you get people down to the surface? How do you do it efficiently?
While the Constellation program was canceled by the Obama administration, word got out about Compass's expertise. This team can deliver a new spacecraft design and scope the costs in just 2 weeks. And it all starts with a wild idea.
A new technologist will bring their new power system to us and say, here's a reactor, I want to put it on the moon. How would I package it? How would I land it? How would I operate it? To us, every new environment, every new place to go requires a new vehicle. So these vehicles, a lot of times they're spacecraft, but other times they're rovers and submarines. It's always something new, but we do about 16 designs a year. Our mantra is base it on physics. There could be new technologies that need to be developed. We try to infuse those into our design, but it's still something that is based on physics.
There are so many different spheres of expertise that go into designing a new spacecraft, like propulsion, materials, and software, and they're all woven in simultaneously during the development process.
Imagine something flying through space has to have, obviously, a structure to it. It's going to need power. You may be able to talk to it, right? So you have the science instruments that gather data. So you got to send back the data with a communication system. We have to have some kind of radiator, some thermal system to keep us at the right temperature so things don't get too hot, things don't get too cold. Of course, propulsion to get us to stop or start or go wherever we're going to go. Finally, trajectories. So how do we get to there and get back again? Ultimately, though, we want to lay this whole thing out so we have a computer configuration. They look really great and they can be feasible, but will it cost too much? Is this something that's affordable for this approach? So we have people on the team to do all those things.
To get all these team members to work together, the team really has to think outside the box.
We do need them to know what the box is that they're trying to get out of, but communication is really the key. I'm kind of like the game show host. One of my biggest roles is getting the creativity out of people. We often combine electric propulsion with chemical propulsion, which one would think those are at odds with each other, but it turns out chemical propulsion is really great when you're near a planetary body. Electric propulsion is fantastic in deep space. But the technologies were already there, but how do you combine those together in a new way? So that's the creativity.
With all of these emerging discoveries, NASA's problem isn't trying to find places to go, it's figuring out which place to go first.
Titan is a wonderful place. It's got a very thick atmosphere. Except for the temperature, if I put you on Titan in the spacesuit, you could put on some wings and you could flap around and fly because the gravity is so low and the atmosphere is so dense. You can splash down in the sea and become a submarine.
So where do you even start when you have to conceptualize a submarine to float 1.27 billion kilometers away on one of Saturn's moons?
The biggest challenge for the submarine was communications and basically going up and down. A boat just has to float. You need to be able to go up and down. So we did ballast systems. But the other big question was communication. So in this case, we were actually talking all the way back up to the Earth. But it turns out that the liquid methane is actually radio transparent. So technically, if you have an orbiter above you, you can sit on the bottom, a kilometer deep, and talk through all that liquid methane. So it's those kind of fascinating things to us. It looks like a regular submarine, but we've done a lot of different things because the environment, the physics are so different on that moon.
Compass's spacecraft designs are based off of the limited data we have so far of these worlds, and hopefully they'll advance our understanding even further.
There's Europa with the 20 kilometers of ice and what could be below in the ocean. We've designed a tunnel bot that would actually dig through there using a reactor to melt its way through. For the Venus Land Sailor, we basically came up with a design that has basically a wing that you would just turn and you would sail in the direction you want. Again, the high temperature electronics are key to making that thing work.
Venus is a scorching 465 degrees Celsius, enough to melt most commercial electronics. To get this land sail to cruise, a team of scientists are working on new integrated circuits that can withstand those high temps.
It's still in the conceptual design phases. You need to demonstrate the high temperature electronics first, and that's what we're doing with some demonstrators we're working on now. So once you get those on the surface, you show they actually work. Now you can start to explore
Because Compass has to dream up the impossible, it pushes other teams to invent new technologies that would power future missions. And that has major benefits for us here on Earth.
A lot of things we've done have not flown yet because it takes, time. One of the greatest things that we did was this thing called Fetch, which basically was going to grab an asteroid. And we're talking, something roughly 10 meters diameter. Actually grab that with this bag and use electric propulsion to push it back. So this is one of the neatest things I think we've done, because this is completely out of the box. Can you actually grab an asteroid and move it back?
This project was part of Obama's asteroid retrieval mission, which pledged to send astronauts to an asteroid by 2025. That mission was canceled by Trump in 2017.
We have a joke here at NASA that every solar cycle, or 11 years or so, we switch from going to Mars to the moon. And that's really what's happened. Bush said we're going to go back to the moon. Then Obama came in and said we're going to grab the asteroid, go to that. And now Trump is here. Instead of grabbing the asteroid now, we're going to basically send the crew to orbit the moon. But this same vehicle that we came up with in 2012 is now the power and propulsion element for the Gateway. A lot of things evolve. A one-week study evolved into now the power system and propulsion system for what the astronaut's going to ride on.
At the heart of all these designs, the Compass team enjoys the challenge. They're taking futuristic sci-fi designs and making them real.
Science fiction led the way in a lot of space exploration, just with being able to think out of the box. In fact, we have discussions on whether they're a Star Wars fan or a Star Trek fan, right? But we all love those genres. We grew up on them. Seeing science fiction movies, reading the books gives you that mindset that anything is possible and that there are new worlds out there. And the Compass team is developing new concepts so the public can get a better window on all these things, see these new fascinating things, and maybe get a better understanding of maybe how unique we are or how unique we aren't.
Thanks for watching, and make sure to follow Focal Point so you can catch the latest innovations and scientific breakthroughs. Don't forget to share and let us know what you think in the comments below.